Hello, I'm Anna Mackay, and this video is on the derivatives of trigonometric functions. Now bear with me, this is going to be a long video because we've got lots of information to revise as well as this new information. So I'm going to go quickly over this initial bit, writing all this down. These are our functions, sine, cos and tan. Here are our derivatives. The derivative of sine is cos, the derivative of cos is negative sine, the derivative of tan is 1 on cos squared x. Now, if you have a function within sine, you actually have to apply the chain rule because we have a function in a function. So differentiating the first function, you do the trig part, derivative of sine is cos, and then you differentiate the inside function. So you work out f dash of x of whatever that is. Let's practice these. So finding the derivative of x cos x, we have to use product rule here. We've got two functions, the first and the second. So differentiating the first, derivative of x is 1, then cos x, differentiate the first, leave the second, then add where you leave the first and differentiate the second. So we'd get negative sine x. For speed, I'm not tidying up today. Let's just move on. The derivative of this one, again, product rule, first function, second function. So you differentiate the first. When you differentiate an e function, you copy and paste what you have and then differentiate the power. So copy and paste and then differentiate the power and leave the second one. Then you add where you leave the first and differentiate the second. So this second function here, the derivative is cos x. And there's our derivative. Moving on, a tan function, but a tan squared function. So the derivative of this, before we do that, it might be helpful to think of it for tan with the square out here. So it's very easy to see then that it's going to have to be chain rule. So you bring down the power, so we're going to have 3 times by 2. You copy and paste what you see there. You'd lower the power by 1, but because it was a 2, it's going to be lowered to 1, so we don't have to write that. And then you differentiate the inside. So the derivative of tan, when it's got an extra function in it, is we'll put the cos squared of that function, and then you differentiate that part. So we get 4 there. Let's just have some practice working with tan, that is sine x on cos x. So we'll tidy it up a bit. 6 sine of 4x on cos of 4x. And over here, we'll leave that as it is for now, cos squared 4x. Now, these denominators we can group together because they're both cos of 4x. So we'll end up with 3 lots of them. So, and the numbers multiplied together. So we'll get 24 sine 4x on cos cubed 4x. And there's our derivative. Moving on. Now, this is our last question, but it'll take a while. We've got part A and part B. So, finding the gradient of the tangent to f of x equal to x tan x. So we need to differentiate this first of all. So we have f dash of x is equal to, product rule again. Differentiate the first and leave the second. Differentiate the first, we get 1 tan x. Add where you leave the first, differentiate the second. So we're going to get 1 on cos squared x. Tidy that up and we're going to change tan into sine x cos x. So we have sine x cos x plus x on cos squared x. Okay, now we're ready to substitute in pi on 4. So let's do that, and to show what we're working with. Whoops, we want pi on 4. If you want to go ahead and try some of this on your own, feel free to pause the video, go ahead and do that, and come back and check to see if you get the right answer or not. Now, how do I write the pi on 4 with a squared cos? I'm going to use this as an opportunity to revise what that is. Now, if you were to put leave the square here, you can't do that on your calculator. So is this the same as that? But also, is it the same if you put the square just around the pi on 4? I'm just going to use this as a chance to prove to you that it's not. So get your calculators out. Where's my cursor? There it is. Okay, so here's what we're trying to work on. Does this equal that? So let's check it. That's the one that's correct, I can tell you now. So we have cos pi on 4 all squared. Enter. Making sure you're in radians to check that. Going to setup in radians, not degrees. Now, that's where the square goes. But is it the same as just putting the square here around the pi on 4? Let's see if we get the same answer. Cos of bracket pi on 4 all squared. No, it's not. So the brackets are vitally important to be around the whole function squared, not just the pi on 4 squared. And just to prove that the square part, you can't put cos squared x in your calculator. Let's try it. If you did, cos, maybe try the square, then the pi on 4, in case you thought that's what you might do, you get an error. So that's why we have to put the square in a different position, but also get it in the right position around the whole function squared. Going back. Now, it's cleared my screen, but that's fine. I needed the space to write. So going back to f dash x of pi on 4, quickly writing that out. Pi on 4 cos pi on 4 plus, where am I? Pi on 4 cos. So remembering this again, this is pi on 4 all squared. Brackets in that position. Now, what is the value of sine pi on 4 and cos pi on 4? We need to have a revision of the unit circle to work that out. So I'm going to pitch this to the students that are not as strong on that concept. If you've memorized all of the identities here, fast forward this part. Okay, so when dealing with the unit circle, there's only two combinations. There's a pi on 4 multiples, and then there's pi on 6 multiples, which are the 45 degrees and the 30 degrees. So the second part of this part B, we're going to do the other one. So pi on 4. We have pi on 4, the family of that, are the 45 degrees, and they are all combinations of 1 on root 2, and 1 on root 2 for both x and y. Remembering that cos is the x coordinate and sine is the y coordinate. That's how they match up. All right, I've got my notes here. So let's draw a unit circle. We'll draw this here. Oops. We've got our axes. A bit wonky there. And there's our unit circle, radius of 1. Now, pi on 4. We're after one lot of that, so that's 45 degrees. Remember, here's 0 degrees, 90, 180. 45 degrees is going to be halfway in that quadrant, and that is pi on 4. So we are interested in that point there. What is its x and y coordinate? So we are after that. Now, as we were saying, when you're dealing with the 45 degree family, they are all combinations of 1 on root 2. So that means we've got 1 on root 2 here and 1 on root 2. But you always must ask yourself, but are they positive or negatives? Having a quick think, here's the x-axis, and we are in the positive region of numbers for that. So it'll be positive, and for the y, this point here is in the positive region of the y-axis, so it's going to be a positive number as well. So just a refresher, so this is cos of pi on 4, and this is sine of pi on 4. So now we can substitute these values back into our question and then tidy it up and solve. So sine of pi on 4 gave us 1 on root 2, and cos of pi on 4 gave us the same. Now, if you remember, it was actually tan of pi on 4. If you are comfortable, you already know what the answer to that one is. Feel free to use that from that point on. Oh, drat. it just dropped out, but we will push on. I'll carry on from the point that we got up to. We had the fractions, so I'm going to flip and multiply. So what I mean by that is take the denominator, flip it and turn it into a multiply. Same with the second part. Now we had 1 on root 2 all squared, and that's the equivalent of 1 on 2. So we're going to flip that and multiply. So 2 on 1. Simplifying this, you notice that these will cancel out and it'll come down to 1, and the next part will be pi on 2. So I encourage you, as often as you can, check this with your calculator. For speed, I'll tell you that in the run mode, you would get 2.57 for this. Let's check this visually with a graph. Off to our emulator, 2.57 we're after. So here's our function x tan x. Which view window? A standard, no, we're after a trig window. Remember to be in radians, graph that. And we are after the value of the tangent at pi on 4. Shift trace, again making sure your derivative is turned on. Pi, whoops a daisy, pi on 4, we wanted 2.57, there we are, 2.57, so we've got the right answer. Moving on, pardon me, we are now going to do part B of this question, which is using x at 2 pi on 3. So here is our derivative function, and this time we're going to substitute in 2 pi on 3. Let's do that. F dashed of 2 pi on 3. So where we see an x, we're going to put 2 pi on 3. Pardon me. And then working out what is sine of 2 pi on 3. Again, if you are familiar with these identities, feel free to fast forward and solve. But if you're not, work with me while I revise the unit circle with you for this. Okay, so if it's not involving a pi on 4 combination, then it must be the opposite one. So it's the pi on 6 family. If you've forgotten all your identities and you're not sure how to work it out, bear with me here. So we're going to have, if we have pi on 6, that's the beginning of it. That's the equivalent of 30 degrees. Remembering with the unit circle that we've got 0 degrees, then 30, 60, 90, through to 180. Let's work some of those out. The next one, so this is one lot of pi on 6. The next one would be 2 lots of pi on 6, which would simplify down, cancelling out those numbers to pi on 3. That's 60 degrees. Then we're after 3 lots of pi on 6. That's pi on 2. That's equivalent of 90. I won't write them all. We've done 3 lots, so let's do 4 lots of pi on 6. Cancel down, that gets you 2 pi on 3. So that's the one we're after. I'll just finish it off so that you've got a refresher here. Well, that doesn't cancel down, so I'll just cancel that one. Ooh. And then 6 lots of pi on 6 is pi, which is 180. So that's how you can work it out. You just go through and you add on multiples of pi on 6 each time. So 2 pi on 3, where are we in our unit circle? It's 4 lots of 30 degrees. 1, 2, 3, 4. So let's draw it in this quadrant. So imagining dividing that quadrant up into thirds, let's draw it about here. Oh, that's perhaps not the best. Okay, so here's the point that we're after, and that's 2 pi on 3. So we're trying to work out the coordinates of this point, the x and the y, which is the cos and the sine values. So, where to start? When we're dealing with the pi on 6 family, they are combinations of, my apologies, a half and root 3 on 2. So the x and the y values will always be one of those two numbers and positive or negative versions. We just have to work out, in this case, which one we're after. My way of thinking about it is this. There are lots of different ways. One of them is always going to be a half. So let's have a look at this point on the unit circle. Draw a dashed line across to the y-axis and the x-axis. And down here. One of those 2 points will be a half. Let's look at the y. Well, that point there looks a long way up the y-axis, nearly to the edge of the unit circle. That looks like it's more than halfway up. But coming along the x-axis, between here and the edge, that looks about halfway. So therefore, this will have the half coordinate, which is on the x side. So if we have our coordinates, it'll be a half there. I'm not finished though. And therefore, the root 3 on 2 will go in the y position. And then think about which quadrant we're in. Our x, if here is 0, here's our x-axis. We are in the negative region for that. So we're going to have a negative x coordinate. For the y, we're in the positive y region, so it's a positive root 3 on 2. So there's a quick crash course in how to work out that family, the pi on 6 family. Substituting that back in. So sine of 2 pi on 3, I'm just going to write this here in case you haven't made that connection. That's cos of 2 pi on 3, and this is sine of 2 pi on 3. So those coordinates. Substituting those in, sine of 2 pi on 3, root 3 on 2, over the cos 2 pi on 3, negative 1 on 2. Substituting that in for the other parts, then we have cos, no we don't, we have negative a half all squared. Now flipping and multiplying our fractions again, root 3 on 2, take the denominator flip and times, so negative 2 on 1, and over here 2 pi on 3, I will tell you that that squared becomes 1 on 4, positive, flip and times, and working them out. These 2's will cancel, negative root 3, add 8 pi on 3. For time, I'll get you to check that with your calculator. I'll tell you that that's 6.65, so that when you check it in your graph by subbing in 2 pi on 3, that's the answer that you should get. Okay, thank you for bearing with me. A long video there. If you liked it, give it a thumbs up and subscribe to the channel. And the next video in this series is called Second Derivatives. Thank you.